Good morning, student. Welcome to the class. This is the fifth part of the chapter structure of atom. And in this part, we will discuss about the Bohr's theory of atom. In the very first class of this chapter, we have discussed about the Rutherford's model of atom. And we have also discussed the drawbacks of Rutherford model. That is the reason because of which this model got rejected. Now, after failure of Rutherford model, another scientist, his name was Niels Bohr, he corrected the Rutherford's model and proposed a new atomic model. Before going to discuss the Bohr's model of atom, let us remind what was the drawbacks of Rutherford. What is the reason for the failure of Rutherford's model? Because on the basis of that problems, on the basis of the drawbacks, Niels Bohr proposed a new model by correcting it. So let us first explain what was the drawbacks of Rutherford. Rutherford's concept about nucleus was absolutely correct, which was also put forward by Niels Bohr later on. But the main problems associated with the model of Rutherford was the path of electron. Rutherford proposed that the electrons revolve around the nucleus. But he told us that electron revolves around the nucleus in random pathway. Okay, it revolves around the nucleus in random way. There was no any fixed path, just electrons was revolving around the nucleus according to Rutherford. Now the problem is, when a charged particle moves, it continuously emits energy. So according to Rutherford, if the electron revolves around the nucleus continuously, then on this continuous motion, it will release energy continuously. As a result, the pathway of the electron will shrink down, and at one time it will get collapsed in the nucleus. That was the major drawbacks of Rutherford. Okay. So in this picture you can see here, this is the electron. If it moves like this and continuously emits energy, this electron, this is continuously radiating, that means releasing energy, then its pathway will shrink down, at one time it will get collapse of the nucleus. So in order to correct it, Niels Bohr proposed his famous model of atom. How he corrected the Rutherford's model? He proposed that electrons revolve around the nucleus. That's true. But these electrons can revolve around the nucleus only in some fixed path. Only in some fixed circular path, which is called orbit. Okay, you can see in this diagram, there are some fixed path around the nucleus, and the electrons can move only in this fixed path. And the most important postulates of Bohr's theory is that when an electron moves in this orbit, it cannot radiate energy. Okay, because it is moving with the energy of that particular orbit, and the orbit has a fixed value of energy. So Rutherfordৰ ক্ষেত্ৰত কি আছিলে, ইলেক্ট্ৰনটো কোনো ফিক্স এনাৰ্জি নাছিলে, কাৰণ ইলেক্ট্ৰনটো কোনো অৰ্বিটত ঘূৰি থকা নাছিলে। সো লাহে লাহে এনাৰ্জি সি ৰিলিজ কৰি গৈ আছিলে। কিন্তু বৰে ক'লে যে ইলেক্ট্ৰনটা যেতিয়া অৰ্বিটৰ ভিতৰত সোমাই আছে, অৰ্বিটত যেতিয়া সি ঘূৰি আছে, তেতিয়াহ'লে সেই অৰ্বিটৰ এনাৰ্জিটোতে ইলেক্ট্ৰনটো ঘূৰি থাকে, আৰু সি তেতিয়া কণ্টিনিউৱাছলি এনাৰ্জি ৰিলিজ কৰি নাথাকে। Okay, but there was a problem. There was a problems associated with the Niels Bohr model. What was the problem? That this Bohr model is only applicable for hydrogen. Mainly Niels Bohr proposed this model for hydrogen, and it is also applicable for other monoelectronic system. Monoelectronic system means in which there is only one electron. So only hydrogen is such the atom which has only one electron, and the species like helium positive, lithium 2+, beryllium 3+, these species also have a single electron and they also obey Bohr's model of atom. You know that if a species is positively charged, that means it is deficient of electron. In the very first class, we have already explained about this. So what is the atomic number of helium? Helium has an atomic number of 2. That means there are 2 electrons in helium nucleus, a helium atom. But since there is a positive charge, that means it is deficient of 1 electron. So helium plus has only 1 electron. Similarly, in case of lithium plus 2, lithium has atomic number 3. That means there are 3 electrons and 3 protons. But since it is 2 positive, the species is dipositive. So that means it is deficient of 2 electrons. That means only 1 electron is present. Similarly, in case of beryllium 3 positive, it has only 1 electron, although beryllium has atomic number 4. That means in neutral beryllium atom, there are 4 protons and 4 neutrons. But in ion beryllium 3 plus, there is only 1 electron. So hydrogen, helium positive, lithium 2 positive, and beryllium 3 positive, which have only 1 electron, they can only obey the Bohr's model of atom. Okay, so let us discuss the postulates and points put forward by Niels Bohr. So postulates of Bohr's model, number 1, the electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbit or stationary state. It is also called energy states. Okay, or energy states. ইয়াক আমি energy states বুলিও কওঁ. Okay, and the second point is each orbit or cell has a fixed energy and the electron cannot radiate energy when it is moving in a fixed orbit. So eto kotha moi already koi ahilu je kisuman fixed orbit thake, ei orbit bilakor energy aru radius fixed thake, aru electron ta jetia ei energy orbit bilakot ঘূৰি ফুৰিছে তাহাতি energy radiate by absorb কৰিব নোৱাৰে. But the electron in an atom move from lower energy level to higher energy level by gaining the required amount of energy, and electron moves from higher energy level to lower energy level by losing some energy, losing the required amount of energy. So when the electron moves in a particular orbit, it is moving with the energy of that particular orbit. It is not continuously emits energy when it is moving in a particular energy orbit. But if it gets some energy which is greater than the energy of that particular orbit, then it will jump from a lower energy orbit to a higher energy orbit. Okay, and if it release some energy, then it can again come from the higher energy orbit to a lower energy orbit. Are you getting the point? So electron can jump from one orbit to another orbit. When it is in a same orbit, it has the fixed energy. But if it moves from lower energy to higher energy orbit, then it will release some energy, absorb some energy. And if it jumps from the higher energy orbit to lower energy orbit, then it will emit some energy. So this electron, can you see here? This electron, it is moving from a lower energy orbit to higher energy orbit. So therefore, it is absorbing certain amount of energy. But this electron, it is coming from a higher energy orbit to lower energy orbit. That means it is radiating some energy. That means emitting some energy. ঠিক আছে? Okay. So electron jetia eta orbitot ঘূৰি থাকে তেতিয়া হি energy radiate নকৰে, কিন্তু যেতিয়া হি এটাৰ পৰা এটালৈ জাম্প কৰে তেতিয়া হি energy radiate by absorb কৰিব. যদি হি লোৱাৰৰ পৰা হায়াৰলৈ যায় তেতিয়ালে energy absorb কৰিব, আৰু যদি হায়াৰৰ পৰা লোৱাৰলৈ আহে তেতিয়ালে energy emit কৰিব. Next point to আহিলে, the stationary states for electrons are numbered as n equal to 1, 2, 3. These integral numbers are known as principal quantum numbers. এই অরবিট বিলাক কিহেৰে ডেজিগনেট কৰা হয়? n এৰে ডেজিগনেট কৰা হয়, n, আৰু n ৰ ভ্যালু কি বুলি দিয়া হয়? 1, 2, 3 এনেকে ধৰণে দিয়া হয়. সো ফাৰ্স্ট অরবিটটোৰ নাম কি? n equal to 1. ফৰ ফাৰ্স্ট অরবিট n equal to কিমান? 1 হয়. সো অরবিট বিলাক কিহেৰে বুজাও? আমি n এৰে বুজাও. ফাৰ্স্ট অরবিটৰ কাৰণে n equal to 1, for second orbit n equal to 2, for third orbit n equal 3, for fourth orbit n equal 4, for fifth orbit n equal 5, for sixth orbit n equal to 6, and so on. Okay, and this n is called principal quantum number. So what does principal quantum number indicates? Principal quantum number indicates about the number of cells or number of energy states or number of the stationary state or the orbit. Okay, next point to ki kole, that the frequency of radiation absorbed or emitted when transition occurs between two stationary states that differ in energy by delta E is given by nu is equal to delta E by H. ঠিক আছে এতিয়া এই কথাটো ইয়াত চোৱা মই এক্সপ্লেইন কৰিছো কথাটো let us consider this is an orbit মই ইয়াত straight line আঁকিছো but এইটো এটা circular orbit ধৰি লোৱা so this is an orbit n equal to 1 this is another orbit n equal to 2 suppose an electron is moving from n equal to 1 orbit with energy E1 to n equal to 2 orbit with energy E2 এতিয়া n equal to 1 orbitor পৰা n equal to 2 orbitলৈ যাবলৈ হি কিমান এনাৰ্জি লাগিব সেই এনাৰ্জিটো ইহত দুটাৰ এনাৰ্জিৰ ডিফাৰেন্সৰ সৈতে সমান নহবনে তাৰ মানে ইয়াৰ এনাৰ্জি যদি 5 হয় সেকেন্ড অৰবিটৰ এনাৰ্জি যদি 10 হয় তেতিয়াহলে 5 ৰ পৰা 10 লৈ যাবলৈ তাক এক্সট্ৰা কিমান এনাৰ্জি লাগিব এক্সট্ৰা 5 এনাৰ্জি লাগিব আমি কি কৰিলো 10 ৰ পৰা 5 টো মাইনাস কৰিলো ঠিক আছে সো এ অৰবিটটোৰ পৰা এ অৰবিটটোলৈ যাবলৈ তাক এনাৰ্জি কিমান লাগিব দ্যাট ইজ ইকুৱেল টু ডেল্টা ই তাৰ মানে e2 minus e1 so when an electron moves from n equal to 1 orbit to n equal to 2 orbit it will absorb certain amount of radiation certain amount of energy which is equal to delta E okay which is equal to the energy difference between the two states in between which the transition is taking place আৰু তোমালোকে এতিয়া জানা যে এনাৰ্জি সদায় কিহত এবজৰ্ব কৰে ইন টাৰ্মছ অফ ফোটন এবজৰ্ব কৰে সো যেতিয়া হি n equal to 1 ৰ পৰা n equal to লৈ যাব it will absorb a photon whose energy is similar to that of the energy difference between the two states so delta E equal to e2 minus e1 আৰু ই যেটো ফোটন এবজৰ্ব কৰিব সেই ফোটনটোৰ এনাৰ্জি কি হ'ব এই ডেল্টা ই সৈতে ইকুৱেল হ'ব ঠিক আছে এতিয়া আমি যদি ইহত দুটাৰ মাজত এনাৰ্জি ডিফাৰেন্সটো জানো ডেল্টা ই ইকুৱেল টু h nu then we can calculate the nu for the radiation which is absorbed by the electron for undergoing transition from n equal to 1 to n equal to 2 orbit so when the electron is moving it is absorbing certain amount of radiation and we can calculate the frequency of the radiation of the light which is absorbed by the electron for transmission from n equal to 1 to n equal to 2 orbit কেনেকৈ উলিয়াব পাৰিম যে ডেল্টা ইকুৱেল টু কি হয় h nu হয় h nu মানে কি এটা ওয়েভ প্যাকেটস আৰু ইয়াৰ কাৰণে আমি নিউটো কেনেকৈ উলিয়াম নিউ ইকুৱেল টু কি হ'ব ডেল্টা ই বাই h so delta equal to h nu so nu of the radiation absorbed is equal to delta E by H. So আমি যদি দুটা স্টেটৰ এনাৰ্জি ডিফাৰেন্সটো জানো Planck's constant we know so we can calculate the frequency of the absorbed radiation. Similarly when the electron jumps from n equal to 2 orbit to n equal to 1 orbit so এতিয়া কি কি কৰিছে হায়াৰ অৰবিট হায়াৰ এনাৰ্জিৰ পৰা লোৱাৰ এনাৰ্জিলৈ আহিছে so when the electron moves from higher energy to lower energy then it will emit some radiations okay again the energy of the quantum which is released by the electron will be equal to the energy difference between the two states that means delta E so যেতিয়া হি ইমিট কৰিব সেই ৰেডিয়েশনটোৰ এনাৰ্জিটো কিহৰ সৈতে ইকুৱেল হ'ব ডেল্টা ই সৈতে ইকুৱেল হ'ব সো এই ইমিট কৰা ৰেডিয়েশনটোৰ ফ্ৰিকুৱেন্সিটো আমি একেলগে উলিয়াব পাৰিম সো তাৰ মানে দুইটা একেই নহব জানো একে এমাউন্ট অফ এনাৰ্জি ডিফাৰেন্স আছে সো যেতিয়া এটা ইলেক্ট্ৰনে n equal to 1 ৰ পৰা n equal to লৈ জাম্প কৰিছে ই যেটো এমাউন্ট অফ এনাৰ্জি ল'ব হি যেতিয়া ঘূৰি আহিব যেতিয়া হি ৰিটাৰ্ণ কৰিব সেই একে এনাৰ্জিটো হি কি কৰিব ৰিলিজ কৰিব okay so the energy difference delta E equal to h nu from that we can calculate the frequency of the absorbed or emitted radiation that is equal to delta E by h next point given by Bohr is that we can imagine infinite number of orbit around the nucleus okay we can imagine numerous orbit around the nucleus but in all this orbit electrons cannot be present electrons are present in only some specific orbit okay and the orbit has to satisfy certain condition for electron to be present in it okay so all the orbits are not allowed for electron only some certain orbits are allowed for electron আৰু সেই কন্ডিশনটো কি কোনবিলাক অরবিট এলাউড হ'ব যে in which the angular momentum of the electron is integral multiple of h by twice pi that means only those orbits are allowed for the electron only those orbits contain electron in which the angular momentum is integral multiple of h by twice pi. Now কথাটো আহিলে, what is angular momentum? তোমালোকে most probably momentumটো পাইছা। Okay, momentum মানে কি? অসমীয়াত ক'বলৈ গ'লে ভৰবেগ। So momentum মানে হৈছে it is the product of mass and velocity. So when an object moves in a straight line, then we generally talked about momentum. That means mass into velocity. But when the object moves in a circular path, then we usually talk about angular momentum, which is equal to mvr. Okay, momentum মানে কি? mv, আৰু angular momentum মানে কি? mvr. আৰু angular momentum কেতিয়া উলিয়াম? যেতিয়া বস্তুটো এটা সাৰ্কুলাৰ পাথত গৈ আছে, তেতিয়া momentumটো আমি angular momentum উলিয়াম, আৰু তাত জাস্ট কি এড কৰিছো? নতুনকে টাৰ্ম r টো এড কৰি দিছো। r মানে কি? radius of the path. So if any object is moving in a circular path, then the momentum is generally considered as angular momentum. So angular momentum equal to mvr. mvr means mass into velocity into radius. Okay, so এতিয়া আমাৰ যেটো radius বিলাক সব circular orbit, কি কয়, orbit বিলাক আমাৰ সব circular orbit. So এতিয়া সেই orbit বিলাকৰ যেটো angular momentum হ'ব, সেই angular momentum টো কি হ'ব লাগিব? h by twice pi integral multiple হ'ব লাগিব। integral multiple মানে কি? যে এটা পূৰ্ণ সংখ্যাৰ multiple হ'ব লাগিব। তাৰ মানে either it should be equal to h by twice pi, or it will be equal to twice h by twice pi, or it will be equal to 3h by twice pi, or it will be equal to 4h by twice pi. Okay, so ইয়াত diagramটো তোমালোকে দেখিছা যে we are considering 4 different orbit around the nucleus. For the first orbit, for the last orbit, the mvr value is h by twice pi. The next orbit, the angular momentum value is twice h by twice pi. Next orbit, the angular momentum value is 2.5 h by twice pi. Okay, and the fourth one has 3h by twice pi value of angular momentum. Now in which orbit is allowed for electron? See, first orbit h by twice pi, it is allowed because it is an integral multiple of h by twice pi, 1 into h by twice pi. Second orbit is also allowed because it is twice h by twice pi. It is also an integral multiple of electrons. So electrons can present in this orbit also. But the third orbit, it is not integral multiple of h by twice pi because it is 2.5 h by twice pi. Okay, এটা integral multiple নহয়, এটা পূৰ্ণ সংখ্যাৰ multiple নহয়, ই 2.5 আছে। So এই third orbit টো যেটোৰ mvr ৰ ভ্যালু বা মোমেন্টামৰ ভ্যালুটো কি পালো আমি? angular momentumৰ ভ্যালু 2.5 h by twice pi পাইছো। এই অরবিটটোত ইলেক্ট্রন থাকিব নোৱাৰে because its angular momentum value is not integral multiple of h by twice pi. আকৌ third next orbit to কি হল? 3h by twice pi. It is an integral multiple. That means electron can present here. So electrons can be present only in those orbit in which the angular momentum for the electron is integral multiple of h by twice pi. Next point to ahile ki that the radii of the stationary states of hydrogen are expressed as, ami radius to keneke uliam? Rn equal to n square into a naught, where a naught is 52.9 picometer, or in terms of nanometer, if we express, it will be equal to 0.0529. Excuse me. Thus, the radius of the first stationary state called the first Bohr orbit is 52.9 picometer. ইয়াত যেটো মই কৈছো ফৰ্মুলাটো Rn equal to n square into a naught. ইয়াত n মানে কি? n মানে হৈছে প্ৰিন্সিপাল কোয়ান্টাম নাম্বাৰ। তাৰ মানে কি যে কোনটো অৰবিটত ইলেক্ট্ৰনটো আছে। ইলেক্ট্ৰনটো যদি ফাৰ্স্ট অৰবিটত আছে তেতিয়া হলে বা আমি যদি ফাৰ্স্ট অৰবিটৰ ৰেডিয়াস উলিয়াব খুজিছো তেতিয়া হলে n ৰ ভ্যালু কি হ'ব? 1 হ'ব। যদি আমি সেকেন্ড অৰবিটৰ ৰেডিয়াস উলিয়াও n equal 2 হ'ব। যদি আমি থাৰ্ড অৰবিটৰ ৰেডিয়াস উলিয়াও n equal to কি হ'ব? 3. So for the first Bohr orbit of hydrogen, the radius is n square into a naught, তাৰমানে 1 square into a naught. A naught মানে কি? এটো fixed value, it is a constant, 52.9 picometer. So the radius of first orbit is 52.9 into 1 square, তাৰমানে 52.9 picometer. Normally the electron in the hydrogen atom is found in this orbit. তাৰমানে হাইড্ৰোজেনৰ ক্ষেত্ৰত ইলেক্ট্ৰনটো সদায় ক'ত থাকে? Normally 1 নম্বৰ অৰবিটটোতে পোৱা যায়, but it can get excited to 2 orbit or 3 orbit or 4 orbit. As the n increases, the value of r increases. In other words, the electron will be present away from the nucleus. তাৰমানে কি ক'লে যে যদিহে nৰ ভ্যালুটো বাঢ়ি যায় তেতিয়াহলে ৰেডিয়াসটো কি হৈ যাব ডাঙৰ হৈ যাব আৰু ৰেডিয়াসটো ডাঙৰ হৈছে মানে কি সি নিউক্লিয়াছৰ পৰা আঁতৰি আছে ইয়াত চোৱা this is n equal to 1 orbit তো তাৰ ৰেডিয়াসটো কি হয় সৰু হয় তাৰমানে নিউক্লিয়াছৰ একদম ওচৰতে আছে this is n equal to 6 orbit okay last one this is n equal to 6 orbit nৰ ভ্যালুটো ডাঙৰ হয় নহয় ডাঙৰ মানে ইয়াৰ কি ৰেডিয়াসটো ডাঙৰ আৰু যদি nৰ ভ্যালুটো বেছি আছে তাৰ মানে ই নিউক্লিয়াছৰ পৰা কি হৈ আছে বহুত আঁতৰত আছে সো ৰেডিয়াসটো আমাক কি ক'ব পাৰে radius of the orbit will tell us how much it is closer to the nucleus if the radius is small that means the orbit is closer to the nucleus if the radius is bigger that means it is away from the nucleus okay okay so similarly আমি ফার্স্ট বোর অরবিটৰ কাৰণে n equal to 1 হ'ব সেকেন্ড বোর অরবিটৰ কাৰণে n equal to 2 হ'ব সো এটো আমি ভ্যালুটো উলিয়ালো এতিয়া সব মই আগতে কৈছো যে বোর থিওৰিটো অকল হাইড্ৰোজেনৰ কাৰণে এপ্লিকেবল নহয় ইট ইজ অলসো এপ্লিকেবল ফৰ other monoelectronic system like helium positive lithium 2 positive etc so for these elements for these species other than hydrogen the radius of stationary state for monoelectronic system other than hydrogen the formula is a bit different okay the formula is Rn equal to n square a naught by z where z is atomic number so for hydrogen the formula is n square into a naught but for other atoms like helium lithium beryllium if you are asked to calculate the radius then it will be equal to n square a naught by z you have to divide the whole term by z where z means the atomic number here the first Bohr orbit of helium positive ion is shown so n is equal to 1 because it is first orbit and what is the value of z for helium the value of z for helium is 2 so accordingly you will get the result similarly for second Bohr orbit also you will get the result here okay next point the most important property associated with the electron is the energy of his stationary state আমি যে কৈছো অরবিট বিলাকৰ এটা ফিক্স এনাৰ্জি থাকে সেই এনাৰ্জিটো আমি ক্যালকুলেট কৰিব পাৰো ঠিক আছে ক্যালকুলেট কৰিব পাৰো আৰু হাইড্ৰোজেনৰ কাৰণে সেই এনাৰ্জিটো কি হয় En equal to minus of RH by n square তাৰমানে এনাৰ্জি অফ nth orbit equal to minus of RH by n square ইয়াত n মানে কি the value of principal quantum number তাৰমানে কোনটো অরবিটত আছে ইলেক্ট্ৰনটো সেই ভ্যালুটো আমি কোনটো অরবিটৰ কাৰণে এনাৰ্জি উলিয়াব লাগে সেই n ৰ ভ্যালুটো আছে সেইটোই যদি আমি ফার্স্ট অরবিটৰ কাৰণে উলিয়াও এনাৰ্জি n equal to 1 যদি আমি সেকেন্ড অরবিটৰ কাৰণে উলিয়াও n equal to 2 যদি আমি থার্ড অরবিটৰ কাৰণে উলিয়াও n equal to 3 so energy expression is minus of RH by n square what is RH it is a constant called Rydberg constant and its value is 2.18 into 10 to the power minus 18 joule. So for first Bohr orbit, minus of RH by n square, eto value put koidlo. ঠিক আছে n or value কিমান 1 so eto answer pala. So যদি আমি second Bohr orbit কাৰণে এনাৰ্জি উলিয়াও তো n or value to কি হয় 2 so 2 square koidlo result পালো এতিয়া যদি আমি আদাৰ monoelectronic systemৰ কাৰণে এনাৰ্জি উলিয়াবলৈ যাও the energy of the stationary state for monoelectronic system other than hydrogen তাৰমানে কি helium positive lithium 2 positive and beryllium 3 positive তাহাতৰ কাৰণে যদি stationary state এনাৰ্জি উলিয়াবলৈ দিয়ে then this energy will be equal to minus of RH by n square into z square that means it will be similar to that of hydrogen energy but you have to multiply the whole term by z square where z is the atomic number so energy of the first Bohr orbit of helium positive En equal to কি হ'ব heliumৰ কাৰণে ইয়াত n or value কি ফার্স্ট অরবিট বুলি কৈছে n or value 1 কিন্তু z or value টো ইয়াত কি হ'ব হিলিয়ামৰ কাৰণে z equal 2 so 2 স্কয়াৰ টাইম মাল্টিপ্লাই কৰিব লাগিব তেতিয়া তুমি আনসাৰটো ইয়াত পাই যাবা ঠিক আছে so next আমি এটা ইয়াত কোৱেশ্চন সলভ কৰিছো the energy associated with the first Bohr orbit in the hydrogen atom is minus 2.18 into 10 to the power minus 18 joule per atom what is the energy associated with the fifth orbit and calculate the radius of the Bohr's fifth orbit of hydrogen atom simply just formula বহাই দিছো minus of RH by n square আমাক fifth orbitor কাৰণে উলিয়াবলৈ কৈছে so n ৰ ভ্যালু কি 5 ঠিক আছে similarly radius টো কি আছিল আমাৰ a naught into n square আছিল so a naught ৰ ভ্যালুটো ইয়াত ন্যানোমিটাৰত এক্সপ্ৰেছ কৰিছো 0.0529 ন্যানোমিটাৰ into n square so n ৰ ভ্যালু 5 just put কৰি দিয়া ৰিজাল্টটো পাই যাবা এটোটা তোমালোকক কৰি চাব দিছো calculate the energy associated with the second orbit of helium positive what is the radius of the orbit so formula ইয়াত দিয়া আছে En equal to minus of RH by n square to z square it is energy of the second orbit energy of second orbit বুলি কলে কি হ'ব n ৰ ভ্যালু 2 আৰু radius of second orbit value দিয়া আছে formula dia ase n square a naught by z. Just put the value of z and n, you will get the answer. Okay, please do this numerical at least. If you do the homework or this numerical problem, then the concepts will be clear for you. If you do not solve any numerical problems, then you cannot understand the concepts clearly. Okay, so whatever I will ask you to do, please do it at least for your sake. Please do it and submit it for WhatsApp. Okay, thank you very much, and also please subscribe the channel, because after completing the chapter I will upload some uh, video related to the this chapter, structure of atom. So then you will get the notification and you can again check the video. Okay, so for this purpose, please subscribe the channel. Okay, thank you.